Hi all of you. I am Harika from EEE Department A section first year. Today I am discussing about characteristics of PN junction diode. PN junction diode. In subtopics about it. Introduction to PN junction diode, forward bias characteristics, reverse bias characteristics, current voltage relationship, forward voltage drop, reverse breakdown voltage, capacitance, temperature depends, applications, summary. First we have to discuss about introduction to PN junction diode. Introduction to PN junction diode. The PN junction diode is a two-terminal electronic component made up of P-type and N-type semiconductor materials. It allows current to flow in only one direction from the p-type region to the n-type region. The characteristics of a p-n junction diode depend on its forward and reverse bias condition. Forward bias characteristics. In forward bias, the p terminal is connected to the positive terminal of the battery and the n terminal is connected to the negative terminal. The deflection region becomes thinner, allowing majority carriers to flow across the junction. The diode has a low resistance and allows a significant current to pass through. Reverse bias characteristics. In reverse bias, the P terminal is connected to the negative terminal of the battery and the N terminal is connected to the positive terminal. The deflection region widens, preventing majority carries from crossing the junction. The diode has a high resistance and allows only a small leakage current. Current voltage relationship. The current voltage I minus V relationship of PN junction diode can be described by the Shockley diode equation. E- Shockley diode equation. I is equal to I naught E cap V by VT minus 1. I is the diode current. I naught is the reverse saturation current. V is the applied voltage and VT is the terminal voltage. At low forward biases, the diode behaves like an open switch, and at high reverse biases, it behaves like a closed switch. Forward voltage drop. The forward voltage drop across a PN junction diode is typically around 0 to 0.6 to 0.7 volts for silicon diodes and 0.2 to 0.3 volts for germanium diodes. This voltage drop is constant over a wide range of forward currents. It is important to consider this voltage drop when designing circuits using PN junction diodes. Reverse breakdown voltage. Reverse breakdown voltage is the voltage at which the diode starts conducting in reverse bias. It can be categorized into two types: Zener Zener breakdown and Zener Zener breakdown and Zener breakdown and avalanche breakdown. Zener breakdown occurs in heavily doped diodes, while avalanche breakdown occurs in lightly doped diodes. Capacitance. PN junction diodes exhibit a capacitance effect due to the deflection region acting as a dielectric. This capacitance is called junction capacitance or deflection capacitance. It affects the high frequency response of the diode and is an important consideration in high frequency applications. Temperature depends. The characteristics of a PN junction diode are influenced by temperature. The reverse saturation current increases as temperature rises, leading to a higher leakage current. The forward voltage drop also slightly decreases with increasing temperature. Applications. PN junction diode have various applications including rectification, voltage regulation, signal modulation, and switching. They are commonly used in power supplies, radio frequency circuits, light emitting diodes, LEDs, and solar cells. The specific characteristics of PN junction diodes make them suitable for specific applications. Summary: PN junction diodes are two-terminal electronic components with specific characteristics. They have forward bias and reverse bias characteristics with different current voltage relationships. The diode's forward voltage drop, reverse breakdown voltage, capacitance, and temperature depends are important consideration. Thank you to all. Thank you so much for giving this opportunity. Thank you.